So hi guys, the goal of this video is to make you comfortable with shuffling. And uh, the question would be, why do we need shuffling? And the answer is pretty simple to that. We want similar kind of data to be there in one place. Um, you may say like, but we are doing parallel processing, right? Like, why do we require everything to be at a single place? Like group by, we create local results. But at the very end, we need those results, those local results to come at one place, and we need to aggregate them to get the sum or the actual total results. Today, we'll be talking about joins and how shuffling happens during a join operation. In front of us, we have two nodes, and each node contains three executors. The squares which we might be seeing in front of us, the green squares and the orange squares, are basically partitions of the green will be of table A, the orange will be of table B. So when we write something like I want to join these two tables, which is table A and table B, on let's say ID column, and I want to do an inner join, what the driver will do is it will tell all the executors like, hey, we need to shuffle. This is the ID, use it, and we start shuffling, right? What happens inside the executor? Let's look at that. I'll just bring my face somewhere down here and let's start. In front of us, we can see something new, which is called a hash partitioner. What hash partitioner will do is it will do a hash partitioning. What is this partitioning? And the purpose of partitioning is to basically group similar kind of data. There is a separate post which I've shared on partitioning, which I'll share somewhere above. But let's take a look about this partitioning. So on the left hand side, we have this partitions of table A, and every single partition will have this records. This is basically our ID column, which is having values 1, 2, and 3. What hash partitioner will do is when the record comes to this hash partitioner, it will create a hash value. Now, based on this hash value, it will put this record into a partition. So the records which are having the same hash value will go to the same partition. So since 2 will have a different hash value than 1, it will go to a separate partition. Similar goes with 3, which will have a separate hash value, which will go to a separate partition. 2, since this has a hash value similar of the earlier record, it will go to the same partition. And same goes with 3 and 1. Now there needs to be some upper limit to this, right? And I'm very sorry. I think I would need to move my face from here. I'll put somewhere over here. So there needs to be some upper limit to this, right? Like how many partitions I can create. And this is where the spark.sql.shuffle.partitions comes in. It will create during a shuffle phase, it will only create the default value of those partitions. Now it is customizable. We can customize it. But the default value is 200. Now this uh, partitioning happens for every single partition present in the executor. Now this happens in all the executors parallelly. So in the second partition, we have this records, they will group together. So every single partition will go through this step. Now once this gets completed, the right hand side or the partitions which we are seeing, the results are stored into shuffle files. Now this could be present in memory or they could be present somewhere in the executor where the executor knows the location of these files. What executor will do is it will pass this information or this metadata to the driver, saying like I have created this shuffle files, I have created this hash value, I'm giving this to you. Like this, every single executor will give this metadata to the driver. So on the screen, you will be seeing a lot of circles and there are values. Um, but this represents the records for that table and the value represents the value of the ID column. So the orange circles represents the records of table B. The green circles represents the records of table A. The other thing which you might notice is the size of the circles. The bigger the size, the more record it has for that value. Just like in executor 3, it has a lot of records having value 3. Now what driver will do is it will send the metadata to all the executors about like which executor contains which partition or the shuffle files, where it is stored, and what hash value it contains. So, and the second thing what driver will do is driver will assign a certain executor like you need to fetch this hash value. Let's say, for example, the executor 1 has been assigned to only collect values which are having 1, right? So based on what the executor has been assigned, it will fetch those values using the metadata which driver has shared. Like the value of 1 is present on executor 4, on executor 6, and executor 2. So what executor 1 will do is it will ask executor 4, executor 6, and executor 2 that I need these files, which they have created on their own and they have kept it on the locations, right? The shuffle files. And let the shuffle begin. And this is what shuffling is. Like all the data having the value 1 goes to executor 1. All the value having 2 goes to executor 5. And for 3, it goes to executor 3. Now bad luck is executor 5 is only having the value of 2 and we don't have any data for table B. And we are doing an inner join, so it won't give any benefits out of that. On executor 3, we have a lot of data. And this gets very interesting because if the executor is not able to hold that data even after spilling, if it spills, then it will take longer to compute or do computation. And if it is not able to handle that, it will give us out of memory errors. This is a scenario of data skewness, and there are techniques like salting which we can use so that the data gets distributed evenly to other executors as well, which are idle right now. And yeah, so this is very so once the data gets allocated to separate executors, like similar data gets allocated to every single executor, then happens the joining. Now, based on the joining strategies, like whether it would be a sort merge join, a shuffle hash join, um, the join happens. But for this video, I just wanted you to see how the shuffle happens. Now, we have taken a very small example where we have only IDs 1, 2, 3. Now, what happens if we have more IDs, right? In this case, we have 1, 2, 3, 4, 5, 6, and they could be, um, it's a mix of both the tables for now. Let's just forget about the tables and see how the shuffle will happen. So here it goes, 1, 2, and 3. You see, it's so amazing, right? And yeah, this is what shuffling is, to group similar kind of data into one place where the aggregation can happen. Now, there are some limitations to this or some bottlenecks, like we talked about um, the shuffle files. There is a bottleneck over there. If you know, just comment down below. And what are the alternatives which you could do to stop or to minimize the risk of this bottleneck? And if you have any other questions or any other thing which you would like me to cover, do let me know. Bye.